Hello students, welcome to my channel. Today I am going to discuss the topic on kinetics of enzyme catalyzed reaction, or it is also called as a Michaelis-Menten equation. And these equations are most asked question in examination. So let's begin the video. The Michaelis-Menten equation discovered by the biochemist L. Michaelis and Miss Maud. This equation is very important for the determination of the enzyme catalysis. And here this equation has a two-step. The first step is the formation of enzyme substrate complex. And the second step is the decomposition of the complex, that is into the products. Here in the first step we have taken the enzyme and the substrate, which gives rise to the enzyme substrate complex. So in the second step, decomposition of the complex into the products. And here the enzyme and the substrate that gives rise to the products and the enzyme. So then apply the steady state approximation. In steady state approximation, we have to differentiate all the reactants one side and the products one side. D is concentration of Es divided by dt is equals to K1 concentration of E and concentration of substrate minus K minus 1 concentration of Es minus K2 concentration of Es. That is equation number 3. Here total energy is equals to free energy plus intermediate energy. E is equals to E naught minus Es. Put this above equation in equation 3. D concentration of Es divided by dt is equals to K1 concentration of S. Here in the place of concentration of E we have to put E naught minus Es minus K minus 1 concentration of Es minus E2 concentration of Es. Here K1 E concentration of S concentration of E naught minus K1 concentration of S and concentration of Es minus K2 concentration of Es. Here we have to take a common concentration of Es one side and put another side on the K1 concentration of E naught concentration of S is equals to concentration of K1 concentration of S plus K minus 1 plus K2. So here we have to bring this equation here below. So it becomes concentration of Es is equals to K1 concentration of E naught into concentration of S divided by K1 concentration of S plus K minus 1 plus K2. This is taken as equation number 4. Here we have to consider rate is equals to d into P divided by dt. That will becomes K2 concentration of E into S, that is taken as equation number 5. From equation 4 and 5, in the equation of 5 we have to put value of concentration of Es, here K2 into K1 concentration of E naught into concentration of S divided by K2 plus K minus 1 plus K1 concentration of S. We have to divide numerator and denominator by K1. Here it becomes rate is equals to K2 concentration of E naught concentration of S divided by K2 plus K minus 1 divided by K1, and here it will becomes plus concentration of S. Here overall the Michael-Menten equation here R is equals to K2 concentration of E concentration of S divided by Km plus concentration of S. Here this Km becomes the constant of Michael-Menten constant. Here this equation 6 indicates that when the all enzymes are reacted with the substrate at higher concentration, the reaction will going through a maximum rate. No free enzymes will remains, because here when we apply the enzyme in the reaction, it will becomes free enzymes by the product of byproducts. In previous equation, we have seen that concentration of E naught is equals to concentration of ES. So this will equation put in the equation number 5, it will becomes K2 into concentration of E naught. That is known as the V maximum. That is called as the equation number 7. For this, here we create a 3 cases, which has case number 1 at low substrate concentration. When Km is very greater than concentration of S, here it will becomes R is equals to K2 concentration of E naught into concentration of S divided by Km. So here this all term becomes K dash into concentration of S. Here this case will follows the first order of reaction because of the concentration of substrate. Here it tells about the first order of kinetics. Here the case 2 at the high substrate concentration. Rate approaches the V maximum and it becomes the independent of concentration of substrate. Here Km is very less than substrate. Then the equation 6 becomes R is equals to K2 concentration of E naught into concentration of S divided by concentration of S. So here the S and S will get cancelled. Here K2 is into concentration of E naught, which is known as the V maximum in equation number 7. So it shows the zeroth order of concentration, zeroth order of kinetics, because it has no substrate. So it shows the zeroth order. So here consider the case number 3, when the Menten constant is equals to the concentration of substrate. So here the equation 6 becomes the R is equals to K2 concentration of E naught into concentration of S divided by 2S. So here S and S get cancelled. 1 by 2 K2 into concentration of E naught becomes V max. So R is equals to 1 by 2 V maximum. If the smaller of Km value, the enzyme binds to the substrate will becomes very strong. If the larger of the Km value means the enzyme binds substrate will become very weak. So here the graph will says the all of this enzyme catalysis. So here we plot a graph between the rate and the substrate. So the graph will gradually increases but at certain time it goes on constant, because the substrate will becomes or remains constant. So because of this that the zeroth order of kinetics will occurs. So I hope you all understand what is mean by the Menten equation. If you have any doubts, please comment below. And we see, I hope you guys all are understand what we have studied now. I hope this equation will be helpful for your examination. Thank you for watching. Please like, share and subscribe. Meet you in the next video.